Well, welcome back to my series on Westpac Mark IV. And in this part, we're going to be looking at root proving and aspects. So where have we got to so far? Well, we looked at the process for setting a root. And if you remember, that involved the signaler pressing and releasing the entrance button, and then pressing and releasing the exit button. We had a look at that complicated circuit involving UZRs, CURs, and LURs, which combined to set and lock the root, making sure that each section was available. And with the root now fully set and locked, it's time for us to look at the signal. So let's just remind ourselves, in UK, the aspect level is dependent on the class of the root that has been set. And that affects both the type of aspect and the timing when the aspect is displayed. The aspect proves that the root is fully set and locked. The aspect also proves all the points in the root are set, locked, and detected. But in addition to those points in the root, we may also want to provide trapping protection for the root by proving extra points. And similarly, there may be train detection both in the root that needs to be proven, and that will depend on the class of root, but also train detection sections which are foul of the root. We also need to think about any overlap. Unfortunately, trains don't always stop at red signals, and so we may need to reserve some line beyond the exit signal. And there may be approach release or junction controls in place, which need to be catered for. All this needs to be combined into the Westpac sets and as standard a way as possible to minimize the amount of specialist wiring and bespoke design. The way this is achieved is with three class-based lines or circuits and a return. The MUCR provides all the conditions specific to a main aspect, and that would include a warning class of route as well. A CUCR is for a call-on route, typically into an occupied platform to enable another train to couple up or to share the platform. And lastly, a shunt UCR proves the conditions relative to a shunt, often may not include all the train detection sections. The UCR return proves those conditions which are common to all of the classes of route, typically that the route is set and locked. So if you remember, we have our layout and we are considering a route being set from 8 on the middle left to 6 on the far right, and that passes through the two turnouts. Both of our circuits that we're going to be looking at start at the exit signal. The B50 or positive feed goes out on one of the three class UCR lines, and the N50 or negative goes out on the UCR return, and it works from the exit signal back to the entrance. So in the exit signal, we have some contacts to feed out on the MUCR. The selection of which UCR line to energize is based on the UFR, the route finish relay. So in this case, we're talking about a main route, so the M/W UFR is energized. We also prove that the first track in the route that forms an overlap is clear, the FTPR. Within the sets, some of the tracks are repeated into the set. And lastly, before we send out the feed, we need to prove that 6 signal is lit using the ECPR. As you can see, there are other options, and one of those options is an old-fashioned practice of lamp or controls. By strapping HB0 to HE5, that would make the circuit go over either the ECPR, the lamp proved, or the UCR, the signal being in a proceed state or off. And that was lamp or controls. But in this case, we're just proving the ECPR. The CUCR at the bottom of the screen doesn't get a feed because the CUFR is de-energized. And there's that link where we can make lamp or controls. The SUFR is also not energized because we haven't set a shunt route, so the SUCR line will have no feed. But let's move our attention to the bottom and the UCR return. The N50 is fed over the UFZPR, a relay that proves that one and only one UFR is energized. It also feeds over the UNR, the route normal relay, saying that the set is in use for the normal direction of traffic. So we now have feeds leaving the exit signal set, heading back through the network of the Westpac sets. The next set we encounter is one of the sets of points, in this case 202. And the MUCR circuit enters on BA7. You'll see that the MUCR enters and leaves on A7. It is only the color that changes. Within WS1, it confirms that the normal points calling relay has been energized, NCUPR. It then proves the track over the points is clear with TP1R before feeding on to the next set in the sequence. The use of the calling relays, RCUPR and NCUPR, prevents false feeds running around the network. Moving to the UCR return, the circuit enters on BA0 at the bottom and passes through an aspect disconnection link. If any of the routes are not available, the disconnection of this ADL will prevent the aspect clearing, even though the route may be set. The next contact, the NCULPR, confirms that the points have been called and locked into the normal position using the combinations of the CUR and the LUR. The NKLZPR is a relay that proves that the points have been called normal, they're detected, locked, and proved. And that enables our feed to continue. We now encounter a series of straps within plug coupler F. And this is where we would put any extra special controls relating to perhaps flank points or foul tracks. We'll look at those in a moment. And then the circuit will continue on having had those extra conditions added to the next set in turn. So let's have a look at how those extra contacts might be wired in. Instead of jumping from FE4 to FD4, FC4 to FD4, we can add some external contacts. And here's an example. Various contacts of point proving contacts and tracks have been added between FC3 and FC4. These are proving that flank points are in the correct position, trapping protection is in place, and that any foul tracks or overrun tracks are clear. The circuit continues through each of the sets, and the only real points of interest are in those points. But when we reach 8GM, the entrance, we now need to energize the UCR relay. The MUCR feeds in over the first track of the route, FTPR, the GSR, the signal stick relay that proves that the signal has only been cleared once after it was last normalized, and the UER, the route entrance relay. The UCR return, the negative N50, feeds in on BA0 and confirms that the CURCR is de-energized, that the route has been properly called. It then feeds over the UEPR to prove that the route has been set as an entrance, and then will normally feed over the TACL, the temporary approach control link. Whilst inserted, the aspect will clear immediately. If, however, the TACL is removed, then it will require the approach A track circuit to be occupied, with the circuit going over A TPR down. We now proceed up and encounter a contact of YR brackets P. YR brackets P is the relay that proves that the button has not been pulled or other route cancellation has not been initiated. So providing the route has been set, proved, locked, detected, and all the track circuits foul and in the route proved, and the button hasn't been pulled, then the feed will get to the MUCR and the aspect will clear. So I hope you found that interesting. It's quite a simple circuit and very familiar for those of us who have designed aspect level circuits. Next time, we'll have a look at route releasing.